Welcome back to Aurora Tech Channel. In my last video, I did detailed comparisons on this CR-6 SE, the Ender 3, Ender 3 Pro, and Ender 3 V2. Since this CR-6 SE has the best extra value and a $60 off promotion, I decided to buy it. In this video, I will assemble this printer and do some test prints. I will also compare the newly designed string gauge auto bed leveling system to the BLtouch and see which one works better. Let's get started. Let's open this box and see what's inside. The base is quite heavy. Okay, we have a base with the bed, the Y-axis with the motor, and a limit switch. Everything is pre-assembled. We have the gantry with the X-axis, the extruder, the hot end, and these are also pre-assembled. We have the touchscreen, the filament holder, the handle, some screws, the cable, and a row of 200-gram filament. The first thing we need to do is check the power supply. Many printers come with a switch. It allows us to switch from 115 to 230 volts. In the US, we use 110, so we need to flip it to 115. We can now connect the gantry to the base, put it on top, and get the 4 long screws from the bag. We will use these 4 screws to fix the gantry. I prefer to move it to the side of the table so I can tighten the screw underneath. Turn it and put in 2 screws to fix the other side. Now we will connect some cables. This long cable from the base has 2 ends. The short end connects the X-axis and the long end connects the hot end. Make sure they are secure. The filament holder is mounted at the left side of the printer. When you don't use it, you can flip it to the back once it's secured. Then, screw the roll to the filament holder. Next, we will install the screen. Push the bed to the back and you will see the cable for the screen. Fix the screen with 2 screws and connect the cable at the back. Then, we can connect the Z limit switch cable. Finally, connect the Z stepper motor cable. Since this is a dual Z-axis printer, we have 2 Z stepper motors. This printer also came with this handle. It's supposed to go here. However, since we want to fit this printer on that shelf, it would be perfectly fine without this handle. The assembly is now done. This is the easiest printer I have ever assembled. Now we can connect the power cable and turn on the printer. Let's remove the protector films on the screen and the glass bed. The printer is now ready to use. Normally we would start with a test print, but let's start with testing out the string gauge auto bed leveling system first. Since we want to compare the string gauge to a BLtouch, I will use this CR-10S Pro V2, which has a BLtouch pre-installed. First, I will connect the CR-10S Pro V2 printer to my computer and use Pronter Face to get some data. Let's run G28 to home the printer and run G29 to probe the bed. Now we have this set of numbers. We will do this 5 times. Okay, we can copy the data to a text editor and do some formatting. Save it to a CSV file and open it with Excel. Let's set up some formulas to find the standard deviation of the BLtouch. You can see we have actually probed the bed 125 times. We came up with a standard deviation of 0.005596 millimeters. According to the BLtouch website, they claim the accuracy of their sensor is around 0.005 millimeters, which is very close to our actual test. I would say that the BLtouch is very accurate. Next, I will do the same to the CR-6 SE. Use Pronterface again to collect some data, format it with a text editor, and calculate it in Excel. We will use these data from 5 rounds of probing to calculate the standard deviation. As you can see, the standard deviation for the CR-6 SE is 0.00788, which isn't as good as the BLtouch, but I would say it's quite close. Considering that we are printing 0.2 millimeters of layer height most of the time, the BLtouch has an accuracy of about 3%, and the accuracy of the CR-6 SE strain gauge is about 4%. I would say they both work well without any noticeable difference. It seems the accuracy of this strain gauge system is very close to the BLtouch, at least on paper. I am going to print something and see if everything is working normally. I am printing PLA. The printer is now heating the nozzle to 200 Celsius and the bed to 60 Celsius. I am using one of my existing G-code files, which includes a G29 command for auto bed leveling. It looks like the temperature is dropping. It goes to 193, then tries to heat up again. This is a problem, but let's see what happens. The screen also turns off every 30 seconds. I need to keep touching it to keep it on. That reminds me that it's a real touchscreen. It starts to probe the bed. As you can see, the nozzle leaves filament marks all over the bed, but let's just let it print and see what comes next. Now the probe is done. It's going to the starting position, but somehow the printer is losing the position. The y-axis is going above the limit and making some noise. It has now started printing 60 millimeters away from the starting position. It looks like we can't put G29 in the G-code file to let it start auto bed leveling before each print. Let's stop the print and try to select auto bed leveling from the menu. Then, we will start a print without G29 and see if it works. Go to the leveling menu and select automatic leveling. Okay, the nozzle is heating up to 120 degrees, but the bed won't heat. I'm not sure if this works as well as it's supposed to, since the probe may not be the same between a cold bed and a heated bed. Generally, a better way to probe a bed is to probe it at the printing temperature, because the bed will expand a little bit when it's heated. I did another test to compare the probe with a cold bed and a heated bed. The difference is actually almost 0.18 millimeters. That means when the bed is expanded, it's actually 0.18 millimeters closer to the nozzle. But since we will do auto home before each print, the nozzle will probe the bed again. If we do that after the bed and nozzle are both heated, this could compensate for the difference. Okay, the bed leveling is done. Let's do a test print. I will print a few sets of M4 screws this time. It looks like it's working well. As you can see, the screw and the nut are pretty accurate, and I can screw it to the nut without any problems. Doing bed leveling manually from the menu is a temporary fix. What do we do if we always want to do auto bed leveling before every print? Let's open up a G-code file and see if we can arrange the G-code to make it work. Okay, this is one of my G-code files. We can remove the comment lines to make it easier to read. You can see when the G-code starts, it heats up the bed to 70 degrees, reports the temperature, waits for the bed to reach 70 degrees, and then it does the same to the nozzle. This part is to set the acceleration, jerk, feed rate, and flow rate. We don't need to change that. It has nothing to do with our bed leveling problem. When we do bed leveling from the menu, it heats up the nozzle to 120 degrees and probes with a cold bed, but we actually want to probe a heated bed. So, we can duplicate these few lines and do the heating in 2 steps. First, set it to M140S70 to heat up the bed. Then, change the nozzle temperature from our printing temperature 215 to 120. This will make sure the filament doesn't melt and leave marks all over the bed. After that, we can send G28 to home the printer and send G29 to do bed leveling. Remember, the printer will lose its position and crash on the y-axis, so home it again using G28. The nozzle will go back to the center of the bed. Before we can heat it to 215 Celsius, I want to move it up a little bit so it won't heat while touching the bed. We can use G1Z20 to raise it up 20 millimeters. Then, we can heat it up normally using the original G code. After the bed and the nozzle are all heated, home it again to probe the bed, so we can get a new value when everything is heated up and expanded. This should be more accurate. Now, we can start the printing G code. Let's run the G code file and see how it works. First, we will let the bed heat up to 70 degrees. After that, we will heat up the nozzle. It seems the temperature control of the firmware is not very stable. Our target is 120 degrees, but it reaches over 124 degrees, drops down to 114, then finally reaches 122. Then auto home, followed by G29 auto bed leveling. Now run G28 to home it again to help it find the correct position. Then run G1Z20 to move up the nozzle so it won't touch our bed when it heats up to 215 degrees. It's the temperature control issue again. Our target is 215, but it goes down to 212, then drops back to 208, and goes back up again to 218. Finally, run G28 to auto home it again to probe the center of the bed one more time to compensate for the heat expansion. It seems everything is working fine, so let it finish the print. Okay, the print has cooled down. This is a disc for a jar. Its diameter needs to be exactly 46¼ millimeters to fit. After the M4 screws and nuts test and this jar test, I would say this printer is very accurate. Let's talk about what I like about this printer. After I assembled the printer, I didn't do any alignment on the frames, or any calibration for the stepper motors. I also didn't check if the extruder is extruding the right amount of filament. It prints really well. I would say it's doing a pretty good job. The newly designed extruder works really well, and it grips the filament tightly. Some users complain that they experienced under-extrusion. You may need to adjust the screw to make sure it's tight. If you don't have any issues with that, I don't recommend that you open the extruder and take everything out to play around with it. It requires a lot of effort to put it back in. 3. The new hot end also works pretty well. After about 100 hours of printing, most of the time there's no issue when I let it print overnight, with no clogs or jams. 4. The bed clip is very nice. It allows the maximum print volume to be used, but when you use the other clip to fix the bed, you may lose some print volume. 5. The blue LED, which is very useful, especially if you need to see how the first layer is printed. 6. The hot end fans are much quieter. The Ender 3 fan is quite loud compared to this fan. 7. The heated bed cable has improved compared to the old ones. 8. It's using an optical Z-limit switch on the Z-axis. I can't see any notable differences, but it feels more premium. 9. It uses an SD card instead of microSD, but a USB could be better. 10. A filament holder. It's good for space that has limited height. I can fit this printer on the rack, and the filament roll is actually hanging outside of the rack. 11. A nice drawer with better quality tools. 12. A better hot end coupler and cap. It should prevent the Bowden tube from moving when the extruder is doing retraction. However, this printer does have some issues. According to Creality, they have fixed some of the issues on the latest firmware. But I've updated the printer to the v2.0.1.3, which is the latest one, but some of the issues haven't been resolved yet. 1. The temperature is unstable. When it reaches the desired temperature, it drops down and goes up a few times, so some PID tuning inside the firmware may be needed. 2. Auto bed leveling issues. Creality recommended to use their slicer for the CR-6 SE, but it's an older version of Cura. There is no auto bed leveling command in the starting G-code. It works, but it will skip bed leveling before every print. If you add G29 to the starting G-code, you still have the same problem. In fact, adding G29 for auto bed leveling is a common practice, so it should work for every printer. I have another Creality touchscreen printer, the CR-10S Pro V2. Inside the auto bed leveling menu, it has an option. If you select Enable Auto Bed Leveling, it will do this before every print, no matter if you run G29 or not. Creality should just put this feature on the CR-6 SE. 3. Another issue about the firmware update is that you need to know if this printer has 3 different versions of the motherboard, the 8-bit board, which should be discontinued, the V4.5.2 32-bit board, and the V4.5.3 32-bit board. You still need to find the motherboard version of your printer. If you install the wrong firmware, it won't blow up, but it just won't work. You can open up the base and see the version number. It's fine for me, but it may not be fine for everyone. Some information online suggests that there is a hint from the serial number to find the motherboard version. For example, P202J11 means 2020 November. If this number is 12 or less, that means the printer was manufactured before December of 2020. It's using V4.5.2 as the motherboard. For my machine, it's November of 2020, so it should be using a V.4.5.2 board, but it seems this is not the case. 4. The firmware file management. There are 2 places to download firmware, Creality.com and their official store, forums.creality3dofficial.com. I found that the files in these 2 sites were different. I downloaded the one from Creality3dofficial.com, version v2.0.1.3 for a v4.5.3 motherboard, but it didn't work. The printer can turn on and I can move the axis, but the bed and hot end won't heat up. The firmware version is the latest one, which is v2.0.1.3, but it may be a different build, but I don't see any build number for reference. Then I tried the one at Creality.com, but when you unzip the files, there's more than one version of firmware inside. The one that works is located under the 9-language firmware folder. The build number should be 0127. The PDF upgrade log and upgrade guide are also unreadable for some reason. I'm not sure if my Adobe Acrobat version is too new, but the PDFs from Creality3dofficial.com are readable. After I upgraded to v2.0.1.3, it didn't change much, and some issues were still unfixed. You can try another option and upgrade it to the community firmware. I will talk about this later in this video. In conclusion, I consider Creality to be one of the best budget 3D printer hardware makers. They were trying to make this CR-6 SE printer a premium 3D printer in the same class. There are quite a lot of different opinions around the 3D printing community, and people run into different issues. But the good thing is that Creality admitted to all of them and resolved not all but most of the issues. For me, I think Creality's hardware is always good. The build is solid, the strain gauge leveling system design is smart, but the firmware and UI aren't as good as their hardware. The firmware just didn't tweak well enough. The UI is usable, but I prefer the Big Tree Tech UI and the community firmware UI more. I would recommend this printer if you already have some knowledge about 3D printing, so you can fix some minor issues. For beginners, you could just be unaware of these issues. If this is your first printer, you probably won't try to add G29 or edit the G-code file yet, so it will print fine. But the stock firmware really needs to be fixed. Personally, I would worry that there may be problems opening up the printer to check the motherboard version in the beginning, then downloading the firmware from the quite confusing sources, and selecting the correct one from the zip file that contains a few different versions of firmware. I have seen many posts online about people asking for help as they are unable to update the firmware correctly and run into different issues. For beginners, a safer choice would be the Ender 3 V2 or the Sovol SV01. Both of these printers cost around $250 to $260. I have done a video for the SV01, which is this printer behind me. It actually has some great features that both the Ender 3 V2 and the CR-6 SE don't have. You can watch that video if you are interested to know more about that printer. I am very happy with this printer, especially the hardware. I updated to community firmware, which was made by Sebazzz and his team. It works great. They rewrote the code and made a new firmware for the CR-6 SE, as well as the screen UI. Their community firmware makes the leveling sensor work even better, and they added many customizable features like E-step calibration, flow rate, and retraction real-time control. Most importantly, some bug fixes, including a real fix for the G29 issue, which is amazing. Thank you to Sebazzz and your team. You guys have put in a lot of effort in your work and added so much value to this printer. For the complete feature list of the community firmware, I have put the GitHub link under this video. I strongly recommend that you try out this firmware if you are unhappy with the stock one. That's it for this video. If you like this video, please give a like and subscribe to Aurora Tech channel. Normally, my brother and I make one every weekend, so check my channel every Monday and you should see something new. Thank you so much for watching. See you next week.